Hello students, I am Azizi, Professor Electronics. In our previous session, we have developed a circuit on microcontroller that is AT89C51. As we are learning the assembly language programming techniques using MCS 51 family, so we have selected the microcontroller that is AT89C51, and in this session we will learn that how to develop our assembly language programs step by step. So let's start our today's session. Here we can find the circuit which we have developed in our previous session. Here we can find we have connected 8 LEDs with port 0 using ULN2803 Darlington driver, and we have connected 3 switches, that is on port 2.0, 2.1 and 2.2, and here we can see all these switches are active low, as we have discussed in our previous session that what is active low and active high inputs. And here we can see we have connected the LEDs using ULN2803. If any port, that is from port 0.0 to port 0.7 will be high, then the collector for the corresponding input will be low and the LED will be on. In this case, we can say that all LEDs are active high. It means that if the port value will be 1, then the corresponding LED will be on. So we can say that all LEDs are active high. And here we can check we have connected the LEDs in reverse order. That is, the LED representing the least significant bit is connected on port 0.7 and the LED which is representing the most significant bit is connected on port 0.0. Now we change the connection of these LEDs as per binary weightage of the 8-bit number. Here we can see we have connected 8 LEDs. It means that 8 LEDs are representing a byte. So we'll change the connection of these LEDs to represent the proper order of a byte. So here we'll connect on D1 the least significant bit of the port 0, that is port 0.0, and we'll connect D8 with the port 0.7. So first we'll change these connections. And now we'll connect the collector 1 to D1. Similarly, collector 2 to D2. And here we have changed the connections for these LEDs. Now D1, that is LED 1, will represent the least significant bit, and D8, that is LED 8, will represent the most significant bit. Now we'll write our first program for this circuit, and here we can find we have connected 3 switches. So first we'll assign the labels to these switches. And here we'll write that is switch 1, and we will write switch 2, and now we'll develop our first program, that is very simple program, that is if we'll press the switch 1, all LEDs will be on, and if we'll release the switch, that is switch 1, then all LEDs will be off. So let's start writing our first program. Here we can find the program which we have written in our previous session. Now we will write our new assembly language program to switch on all LEDs if we'll press switch 1. So first we'll close this project. Okay, close project. Now we'll develop new project, new microvision project, and here we'll assign the name to our project, that is LEDs and switches. So here we will write that is, so here we have assigned the name to our project. Okay, save. Now we'll select the microcontroller, that is 89C51, and here we have the microcontroller. Okay. No. Go to the target 1, right click, option for target, target 1, and here we'll select the crystal oscillator, that is 12 MHz, 12.0, and we'll go to the output and we'll select create hex file. Okay. And now we'll go to the source group 1, right click, add new item to source group, and we'll select ASM file, and here we'll assign the name, that is LEDs and switches. Okay, add, and here we'll start writing our first program, and we'll start our program from comments. And we'll assign the name to our program, that is LEDs control, and here we will write some variable assignments. First of all, we'll write port assignments. So here we will write that is, and here we'll write ports assignments. So here we'll assign the name, that is LEDs port to port 0. So we'll write that is LEDs port, and here we will use the reserved word of the compiler, that is EQU, equate, and we'll write the name of the port 0, that is port 0, or we can write the hardware address of the port 0 here, and here we can find the hardware address of port 0 is ATH, so we can write ATH instead of port 0, or we can also use the port 0, that is the name of the port 0. So here we have written port 0, or we can replace this port 0 with the hardware address, that is ATH. So here we can write that is ATH, and here we can assign a comment like this, that is port 0. Now we'll assign the labels to the switches which we have connected on port 2, that is port 2.0, port 2.1 and port 2.2. So here we will write that is switch underscore 1. To assign the label to a single bit, we will use the reserved word, that is bit, and we will write port 2.0, and now we'll assign the name to port 2.1, that is switch 2, bit port 2.1 and switch 3, bit port 2.2, and here we'll close the ports assignment session. We can add more variables to port assignments as and when required in our program. So here we'll close this session. And now we'll write the variable assignments. Here we will write variables assignments. And here we will write two variables, that is LEDs on and LEDs off. So here we will write that is LEDs underscore on. We will write EQU, and here we will write the value, that is 255. Here we have written the number in decimal format. It means that all LEDs will be on. As we will move this number on port 0, then the all ports, that is port 0.0 to port 0.7 will be high. Then all LEDs will be on, and here we will write that is LEDs off. EQU 0, or we can replace these decimal numbers with hexadecimal numbers. We can write 0 FFH, it means 255, and here we can write 00H, it means all LEDs will be off. And here we'll close the session of variable assignments. Now we'll write the directives for our compiler. So here we will write that is directives, and here we will write originate, that is org, and here we will write the address from which we would like to start our program. Obviously we would like to start our program from 00H, because if we will power on our circuit, then due to power on reset circuit, microcontroller will go to the reset vector, and that is 00 for the MCS 51 family. So here we will write that is 0000H, and here on 00H we will write an instruction, that is jump to initialization routine, that is ini underscore r, and here we will add a comment, that is initialization routine. And now we will originate another address, that is org 0030H. It means that we want to write our initialization routine from 30H, and we will start writing our initialization routine from 30H like this. And now we'll start writing our initialization routine. So here we will write that is ini underscore r with colon, and here we will write move on LEDs port, that is LEDs port comma hash LEDs off. In this case, the value that is 0 will be moved on port 0, and here we will finish our initialization routine. And now we'll write our main program, and from here we'll start the main program. So we'll write that is main R, and here we will learn some new instructions, that is how to check the status of the bit. As we know, the switches which are connected on port 2 all are active low, so we'll check the low status of the switches, and here we will write that is jump not bit. It means that we want to check if the status of the bit is 0, and here we will write that is switch 1. It means that here we will check that if the switch 1 is low, if the switch will be pressed, then the status of the port 2.0 will be 0, and in this case our program will jump to another routine, and here we will write the routine with comma, that is switch on LEDs. So here we will write that is switch on LEDs. If we will translate this line once again, it means that at this line we want to check that if the switch is pressed, then the status of the port will be 0. In this case, our program will jump to a subroutine, that is switch on LEDs, that we will write now. But if the switch is not pressed, then our program will come on next line, and here we will write that is move LEDs port comma hash. It means we want to move the direct number, that is LEDs off. It means that if the switch 1 is not pressed, then move the value that is 00 on LEDs port, that is on port 0, and jump to the main routine. So here we will write jump main R. After moving the value that is 0 on port 0, our program will go back to the main routine. But if the switch will be pressed, then our program will jump to a subroutine, that is switch on LEDs. So here we will write our subroutine switch on LEDs. With colon, and here we will write move LEDs port comma hash LEDs on, and on this line the number that is 255 will be moved on port 0. After executing this line, we will direct our program to go back to main routine. So here we will write jump main R, and that's all. Our program is completed. And now we'll write the last instruction, that is end, and here we'll write that is end. So here we have completed our program. Let's analyze our program. Here we have assigned the name, that is LED port to port 0, and the hardware address of the port is 80H, and here we have assigned the name to port 2.0, 2.1 and 2.2, that is switch 1, switch 2 and switch 3, and here we have written variables, that is LED on, the value is 255, and LED is off equals to 0, and then we have written the directives for our program, and we have written originate address 00H, that is start writing the first instruction from 00H location, and here we have written an instruction that is jump to initialization routine. From 00H location, our program will jump to the initialization routine, and we have start writing a program that is initialization routine from 30H. So here we have written originate 0030H, and here we have written our initialization routine, that is move LEDs port LEDs off. In initialization routine, our program will move the value that is 0 to port 0, and all LEDs will be off. Now our program will come to the main routine, and it will check if the switch 1 is pressed, then it will jump to the routine, that is switch on LEDs, and it will come here switch on LEDs, and it will move the value that is LEDs on, which is 255 to LEDs port, and all the ports will be high, that is from port 0.0 to port 0.7, and it will go back to the main routine. But if the switch is not pressed, then our program will move the variable as constant, that is LEDs off, and the value of the LEDs off is 0. So the 0 number will be moved on port 0, and our program will again go back to the main to check the status of the switch 1. Now we'll compile our program and we'll download the hex file to the circuit and we'll check the result of our program. Here we can check we have an error, that is undefined symbol. Here we can find we have an error on line 32, that is jump not bit switch on LEDs, and here we have written the subroutine name, and here we can find the subroutine name is not matching with the subroutine which we have written here, that is switch on LEDs. So here we'll modify the name, that is SWITCH, and now we have modified the label according to the label which we have given on jump not bit instruction. Now we'll compile our program once again, and here we can find no error, no warning. Now we'll download the hex file to our hardware which we have developed on Proteus. So here we'll go to the microcontroller, right click, edit properties, program file, and here we have the hex file, LEDs and switches. We'll select the file, OK. Now we'll run the simulation and we'll test the result of our program. Here we can check as in initialization routine we have returned the value that is 0 on port 0, and here we can find all the 8 bits, that is from port 0.0 to port 0.7 are low. But if we'll press the switch, that is switch 1, here we can check all LEDs are on and the program has moved the number, that is 255 on port 0. So all LEDs are on, and if we will release the switch, again the program will move the number, that is 0 on port 0, and all LEDs will be off. So here we have written our simple program, that is to switch on and switch off all LEDs simultaneously. Now we will learn some more assembly language programming on this circuit. Thanks for watching the assembly language programming course. We hope that you find this course very helpful to learn assembly language programming. If you feel that this course contributes and enhances your embedded system design knowledge, then go ahead and hit like, share and subscribe buttons, and do not forget to press bell icon to stay updated with every new upcoming video from Electroeducators as soon as it goes up. Electroeducators also offers technical consultancy in following fields. For assistance regarding technical problems, projects and any consultancy, feel free to reach out at our email address electroeducators@gmail.com. Okay, see you in next lecture.